I have with me today our two speakers, David Brossard, Chief Technology Officer at Axiomatix, and Andre Priebe, Chief Technology Officer at IC Consult. And yeah, I will now hand over to you, Andre.
Thank you very much, Manuela. So having two CTOs in such a session likely will result very technical discussions. So we will now go through a couple of topics around mastering zero trust and how AI can help us in the when it comes to authorization, and then having an interactive discussion and covering questions you provide us during that session. Okay, then let's start with the question, what are the challenges we see around zero trust? And therefore, a very short, recap of what zero trust is. I'm quite sure that we heard about that topic the last years a lot. Yeah, so verify explicitly, use least privilege, very important. And I think that's really the kind of change from the kind of conceptual approach, assume breach. Yeah. However you build a system, that's a kind of core idea having in mind and build everything very robust to, well, still having a high degree of security posture in place, even if the attacker has access to a few of your resources. So how is it achieved? Core idea is very simple. Instead of having a large zone of implicit trust and a small untrusted zone and in place where authentication authorization takes place, we want to make sure that the zone of implicit trust is as small as possible. So so in the perfect world, the size of that zone is really zero. Authentication authorization is enforced and takes place directly when accessing the resource. At the same time, it has to be manageable and so on and so forth. Then another short recap on that. There's that kind of standard architecture approach provided by NIST. There are other architectural patterns out there, but the details doesn't matter. The core idea here in general is following. Having a pattern of a policy enforcement point that is enforcing access to the resources, a decision point, which makes the decision if the access is allowed or not allowed. And now the very important aspect comes into that. This is about leveraging a lot of information that is available within your organization or from providers and partners outside of the organization, and bringing all that thing together by having an evaluation take place for every single request, looking into different aspects of that. So the access request itself. So how's it, so everything related to the request accessing the resource, the subject. For instance, it's the correlation to the topic of identity governance and administration. So who is the user? So knowing about the identity of the user, knowing about the identity assurance level. So is it kind of self-registered user? Is it somebody in the supply chain? Is it an employee? Have you seen ID cards and so on and so forth? So kind of online identity proofing. Then was a kind of access request to access specific resources, having a specific role. Has this been approved? This everything related to that, where that really delivers us more insights into that subject. The asset database, which is related to, for instance, the device the end user is using. Is this an employee using a notebook that is managed by your organization with the latest, greatest patches and endpoint protection and everything that gives us a specific trust into that device? Or is this a complete unmanaged device? We don't know it because we can't know it. It's maybe a device of a contractor, of a supplier, maybe of a customer of us. And then the the information available is much more limited on that. What is important aspect here? Depending on the nature of the user and what we know about the user, about our asset database, we can enforce something that in another situation we can't enforce because we can't know. But we don't want to end up in a situation where we say, hey, there are users where know a lot of things and devices and so on. Other users where we don't know anything, but we have, in that case, following an approach we don't know in all situations, therefore we don't look into devices at all. So we want really leverage what is available, even if the level of security is not the same in every single situation. Well, then we have resource policy requirements. So what kind of resource is there access to? The data being classified? Is it confidential, internal, secret data? Or are there regulatory requirements correlated to that resource and so on? And then all the live information, logs available, giving us risk insights, or threat intelligence information, maybe also from outside the organization, knowing, hey, that supplier accessing our IT systems has been affected by a breach recently. So that might be something what we would like to leverage. Then another important aspect when it comes to zero trust is the question of what kind of maturity do we have? There's one framework from this Cybersecurity Infrastructure Security Agency. There are other frameworks out there. I don't want to go into the details. Typically, the approach is we have different pillars. For instance, identity pillar, the device pillar, and so on the one side, and then maturity levels we can achieve in these different pillars. And I would like to highlight here one situation that is true for most organizations and for our whole industry. I would say we made a lot of progress when it comes to authentication. So MFA with approaches like passkey are phishing resistant, are strong, even if there are a lot of challenges with implementation. But anyhow, in theory, we know how to tackle that challenge, I would say, and there's established standards out there. But when it comes into the pillars like application and workloads, or also when it comes to data and network, then we are not only talking a lot about the authentication piece and assurance piece, but also about the authorization, resulting in that evaluation policy with that 5 steps you have seen before. And honestly, this area is much more challenging than authentication. And I would highlight some of these aspects a little bit to share what we see out there at our clients and organizations we are helping to achieve a high level of maturity in zero trust. So in theory, great, you have a policy enforcement point, we have a policy decision point. But have in mind, we have very different resources out there, different ecosystems, different protocols that are important. And what is the right place from a policy enforcement point? So the policy enforcement point be in the HTTP stream. Then we see HTTP requests, right? And might analyze them somehow, but that's typically a kind of dead end road when it comes to more complex policies or evaluation of policies. So having that kind of situation is a good reason to go for different approaches when it comes for policy enforcement point. There are solutions, vendors, and standards out there for that, but not just one, but a couple of standards. And then it is a question how many policy enforcement points do I have? More policy enforcement points, there's no reason to limit yourself to one, but how many policy decision points do I have? And if I have a huge organization, a high number of policy decision points, that's very hard to manage, which comes to the second challenge. This kind of policy, 5 steps who is the right person to define such a policy? What skill set is required? And typically, you need to have two areas of skills. One is kind of identity access management professional, yeah, being able to build a policy in the given language and knowing about the patterns and so on. And the other is having a very good understanding from the business perspective when it comes to risk. Yeah. Is it kind of resource where we have different user groups with different level of control? What are the regulatory requirements? What is the risk associated with a particular resource? And what is the risk appetite for the business case? Yeah? Especially when it comes to customers. So what do I want to risk in case of not allowing an access to happen and making a customer unsatisfied? And then having in mind that there is typically we are in a very inhomogeneous world out there. So very different aspects coming here into play. And then it will not be a good idea having at the policy decision point a kind of bottleneck when it comes to building the policies. And but really hand over as much as possible of responsibility to the business owners without having the need to educate them in depth how to build such a policy. And this is an area in which I believe AI will play a very important role in the future to help us to move that forward. But also the other challenges like that kind of different standards out there has to be tackled somehow. And therefore, it's great having David here today with me and to jump a little bit into that topic and explain how Axiomatics with other partners in the ecosystem is tackling that challenge and especially help us to leverage AI to get better policies in place. So, David, the stage is yours.
Thanks, Andre. Really, really good points you hit there. I mean, I couldn't agree more with what you said, of course. There is this idea that you do need a policy decision point, you do need a policy enforcement point to protect the enterprise, to protect what it is you're getting access to. But then, of course, the nature of the decision point, the nature of the policies in the decision point, the nature of the enforcement point really depends on what it is you want to protect and what interactions you want to have. So what I'm going to do at first is discuss a little bit how authorization, which is what's very near and dear to me, interacts with zero trust. If you went back 5-6 years, zero trust was not something I really spoke about. It's not something I'd explored, and yet it makes so much sense. So if we move forward to the next slide, Andre, authorization is not something new. Zero trust isn't either, by the way, right? We've been talking about the term for 5-10 years, but of course it's a principle that goes back many years. Authorization as well. Like the very first computer systems back in the 70s, they needed some kind of access control, some kind of authorization. There was this whole idea of MAC and DAC, mandatory access control, discretionary access control, the idea that you could have user group permissions assigned to files and folders in Linux, and little by little that matured into what we know is authorization today. So back in 92, NIST, I saw, Andre, you had a really great reference to NIST on one of your previous slides. NIST published a paper on RBAC, role-based access control. Fast forward to 2013, they published a paper on ABAC. And in particular here, they did a lot of work on how that combines with zero trust. So one of the premises of that is what the NSA back in 2009 called RADAC, Risk Adaptable Access Control. The whole idea that when a user, so we're talking here in the intelligence community, but it applies to any realm really, when a user wants to get access to a piece of information, do they have the right entitlements to do so? Is their device, like you said, Andre, can we get signals from that device to figure out whether the risk level of the user accessing the information is acceptable? Is it a personal device or corporate device? Fast forwarding to 2014, this is NIST when NIST published the Guide to Attribute-Based Access Control, special publication 800-162. It is a really good read. It defines and formalizes the architecture that Andre had on his slide with the PEP, the PDP, the PIP. Sometimes in the field, we call that the P*P architecture because there's so many Ps, if you will. So PEP is the enforcement point. Depending on what it is you want to protect, it will have different form factors. PDP is really the brains of the operations. This is where your policies are being run. PIP is what connects you to external systems to fetch metadata, if you will, to fetch risk scores, to fetch relationship information, all the things you want to use in your authorization decision-making process. Fast forward to 2020, NISP comes up with a zero trust architecture. And what's really interesting with the ZT architecture is that authorization is really an underpinning of that architecture. It's always about never trust, always verify, the idea that every single action, like you were saying, Andre, we're going to be checking that you're supposed to be doing this. This is a departure from the traditional way of doing authentication and authorization, where you enter an app, a session is created, you're getting entitlements, you're getting what I call birthrights because they're given to you at the beginning of the session, and then you could just walk along and do your thing, right? Which is very insecure because by then we don't really know whether you should be doing those things anymore. Now, zero trust got a little bit more heat with the, sorry, go back one slide, with the executive order from the president in 2021, which translated into the reference architecture by DoD, and then eventually the NSA guidance on zero trust maturity, all excellent reads. And then if we move to the following slide, you'll see how the tenets in zero trust relate directly to access control. So there are 7 different tenets that come from NSTAC. NSTAC is the group responsible for telecoms in the US. And of those 7 tenets, 0.3, 4, 5, and 6 are all related to access control. So access to resources granted on a per session basis. You have to be authenticated. We have to know who you are in order to access resource. Access is determined by dynamic policy. So we will look at the different parameters to determine whether access should be granted or denied. Assets are monitored and measured by the enterprise. That's actually really interesting. And Andre, I don't know what it's like with your customers, but when I look at mine, I think they underutilize monitoring of resources. And we're going to be talking about AI a little later. Right now, we're looking at AI to help build authorization, but I think we should also use AI to help listen to all the signals because God knows there are a lot of signals we could take and understand whether access is being breached or not breached. Because there's a side note, by the way. There's 2 kinds of authorization use cases, let's say. There's the kind where we can write a policy and we can make sure that people get access to the right things under the right circumstances. But there's also the kind that our technology can't solve today, which is the rogue employee. And what I mean by that is there are employees that have the right access. They can do pretty much what they're supposed to do for work, and they can abuse that right. They could, an HR employee can view the pay stub of another employee, great, so let them access. But should they really download all 1 million records for the past 12 months for all 100,000 employees? Nah, that looks a little fishy, right? I think AI in the future will be able to help with that use case. And then the last point here is all authentication authorization are dynamic and strictly enforced before access. This is a departure from admin time authorization and moving towards runtime authorization, which is pretty much what NIST advocates for with the PEP PDP architecture, which is what you had, Andre, in your previous slides. So moving on, what does that mean for us, Axiomatics? We see how we can enable a zero trust model through 3 different parts, right? Number 1, access. So we have to have the policy enforcement point. We're going to check what the user wants to do, what they want to do it on. And like you said, Andre, there's a question of what is that PEP? What you're looking at, if it's an HTTP payload, is it interesting? If it's a REST API, is it interesting? If it's even lower on the network level, is it interesting? So you have to figure out where the PEP needs to sit in order to make business sense. And traditionally, typically, I write business policies, things like, a user can view a medical record. But of course, someone in the enterprise might be more interested in transport payloads, things like only allow SSL traffic. That's not really a business policy anymore. It's a technical policy. They're both valid, but you can't have 2 personas write those 2 different policies. And yes, to your point, Andre, definitely AI can help us build that complete picture. The second aspect to the triad of zero trust is adapt. Adapt authorization depending on the information that you're getting from users. So connect to a risk scoring system. If, for instance, you check your account balance from California a minute ago, should you be able to check your account balance from Germany now? The last time I checked, it took a little bit more than a minute to travel from one place in California, say San Francisco to Frankfurt in Germany. I wish it only took a minute, but unfortunately that's not the case. So if you plug into risk services, now you can actually have what you could call maybe fuzzy policies or adaptive policies that are capable of taking that risk into account and delivering better, more meaningful authorization. And then the third tenet, or the third dimension of my triangle, is the transact. So the whole idea that every single time you access, we're going to check that that you have the right to access. We're going to create an audit trail of the fact that you did access or you attempted to access and you got a permitted access or denied access. So we really want to build that authorization flow, if you will, so we know exactly what information is being granted or denied. Moving on. And the way that it works, there's shameless plug for Axiomatics, but it actually applies to any vendor who does runtime authorization. So our competitors will have very similar architectures. At the very core of what we do, we have an engine. It is what NIST calls the PDP in their ABAC architecture. We like to call it policy-driven authorization. Yes, it uses attributes in the policies, but the fuel of the engine is the policies. What's really cool with using policies, and I'm really trying to pronounce policies as much as possible in a minute. I'm kidding. What's really cool with policies is that if they're written well, they can actually mirror the original requirement pretty closely. So if you had a requirement stemming from a compliance role in Germany or maybe from the finance department, you can actually write the policy in a way that bridges the gap between the requirement and the actual technical artifact. Oftentimes, what happened in authorization configuration was that you would have a requirement to do, I don't know, SOX compliance or to do GDPR, and then you would have to go do role engineering. And when you do that, of course, you lose the correlation between the two, and you end up with a gap, a cognitive gap, and therefore you don't know what you're enforcing anymore. With policies, you don't get that. With policies, of course, if you write the policies correctly, you can apply them to any number of systems. On the left, unstructured data like Office 365, SharePoint, Google Drive, so on and so forth. On the right, with structured information like Salesforce, APIs like MuleSoft, Apigee, so on and so forth, or SAP. And then, of course, you're always reading those sources of attributes at the bottom, who the user is, their identity data, contextual data like time of day and location of users' risk. And then if we're talking about data like what you store in SharePoint, classification data. We see a lot of use cases in export controlled industries like air and space, where you want to classify the information. You want to say, oh, this is a US only piece of information. This is a top secret piece of information, and use that in the decision-making process. Moving on. Now, taking a step further into the world of authorization, I'm going to get a little nerdy. There's really three ways today that you can do authorization. We very much believe in the policy-driven world. This is what we've been doing forever at Axiomatics. There are many different standards in the policy-driven world. The historic standard, if you will, stemming back to 2001, stemming back to the birth of SAML as well, is XACML, XACML, the Extensible Access Control Markup Language. But since then, we've seen a lot of evolution in that world. So we have Alpha that came out in 2012, 2013, the abbreviated language for authorization, which is a modern spin on the XACML syntax. We have, of course, in 2015, Rego as part of the Open Policy Agent project. And we even have little initiatives left and right. AWS came up with Cedar, for instance. It's their language to define verified permissions, and you can actually use it for other stuff too. So that's a policy-driven way of doing authorization. What I like with policy-driven is that there's this, like I said before, this correlation between what it is you want to do from a plain old English perspective with the actual implementation in your applications. Also, all of the standards I mentioned here, XACML, Alpha, Rego, Cedar, they tend to focus on the application layer, the API layer. But if you wanted to use them for network access control or other parts of the stack in your Zero Trust initiative, you absolutely can. There's nothing that prevents you from doing that. The second way of doing authorization, and there's no order, by the way, the second way is graph-based access control, leveraging graph technologies to define authorization. This is a big deal if what you want to do is relationship-based access control. So you want to define access based on let's say, ownership of an item, so the owner can view the item. Graph-based authorization is also great if you live in a graph-based world. So if you use GraphQL as an underlying language, or if you've implemented your services using Graph, this is where graph-based authorization can come in handy. It does have its limitations, so if you want to use more attributes, you will have to use a language. It could be TypeScript if you didn't want to pick an authorization language. It could be, of course, any one of the languages listed under policy-driven. And then the third piece is access control lists. Like I said, they're really old. They're from the 1970s. They're not anything new. The reason we moved away from ACLs is for scale. That being said, it goes back also to the dichotomy between discretionary access control, which is what ACLs are great at, and mandatory access control, which is where policy-driven and graph-based authorization come in. And then these models are not exclusive, right? It's not like you're going to be choosing one or the other. When you do policy-driven authorization, you will need to do some kind of access control list, ACLs, or discretionary access at some point. The one thing I do want to call out, I wrote Zanzibar here on the slide. This is a really cool initiative that came out in 2019 by Google. And the driver for Zanzibar is really consistent access control at scale, meaning that if you have a Google Doc that I'm sharing with you, Andre, right? I'm right now on the west coast of Canada. If I configure that doc to share with you, and there's no policy behind it, I just want to share it with you, you should be able to get the access in a split second, right? So there's that consistency challenge that they had in Zanzibar. Moving on. This is a busy slide, but if you look closely, you'll recognize the slide that you had earlier, Andre. You see at the very core, you have your PDP. At the top, you have your policy enforcement point. In the bottom right corner, you have your policy information point that connects you to your underlying resources. And in the bottom left, you have your policy administration point, the last P start P component. This is exactly what NIST ABAC recommends. Again, the whole idea is that you have a user or a client trying to get access to a system, an application, a microservice, an API, whatever that may be. It doesn't really matter. We're going to deploy the PEP. And the bulk of the work, by the way, when you roll out authorization in a zero trust architecture, is figuring out what the form factor of that PEP will be. And to your point earlier, Andre, if we're talking about a proxy, or if we're talking about an API gateway, or we're talking about a filter in SharePoint, the degree of information that those interceptors, those enforcement points can see is a little different, which in turn means that the policy you're writing behind the scenes might be a little different, and the degree of authorization you're doing might be a little different. All of these are legit. You just have to think where it makes the most sense to apply your policy enforcement point. At the end of the day, the key benefit you're getting out of this is consistent authorization across your systems, and number two, consistent definition of the policies in the bottom left corner, and centralized policy management, right? The decision making can be decentralized, doesn't matter, but the management of the policies and the reporting on the policies, you want that to be centralized. Moving on. All right, and so stepping a little bit away from the vendor stuff and the zero trust stuff, let's look at standards. The latest standard really in the world of authorization is something called AuthZen. We like to be very peaceful with AuthZen. It started really in June of 2022 at Identiverse in Vegas, but the work actually really started the following Identiverse 2023. A few of us got together and said, well, there's the graph way of doing authorization. There's the Zanzibar way of doing authorization. There's a policy way of doing authorization. And even within the policy world, there's, Rego, and there's Alpha, and there's Cedar, and there's OSO, and there's Cerbos. So many different ways. But having too many ways doesn't really serve the community all that much. And if you want products, non-authorization products, to externalize authorization, we better have a standard interface. So as it turns out, ZACWL and Alpha did have an interface. The other standards didn't really. So we all got together. We learned from the different ways of doing authorization requests and responses. We got feedback from the different communities, and we defined a standard interface, a request response protocol. It actually is right now in the 45-day review period at OpenID. So if you want to weigh in on the design, please go to the OpenID website for AuthZen, and you'll find the draft proposal. We will be doing another interop at Authenticate in a few weeks now. It's getting really close. The whole point is that we want to make sure that any product, non-authorization product, a Salesforce or Workday, your homegrown app, an API, can plug into an authorization system in a standardized way, so that if you want to use an Axiomatics and then throw it away and use a graph-based approach and throw that away and use an ACL, you can do that. There's two more pillars to AuthZen. One is really defining design patterns. Because so far in this presentation, we've talked a lot about P star P, but there's also the token-based approach to authorization that we haven't really touched on. So what does that mean? Like, which pattern should you choose? What are the pros and the cons? And then, of course, there's education. There's still a whole lot of education. The analogy we draw oftentimes will be comparing with OAuth and OpenID Connect. If you go back 10, 15 years, people were not really clear what OAuth and OpenID would deliver in terms of value. Of course, today, if you bought a SaaS, if you bought a COTS, you would expect that product to be able to plug right into your identity provider using either of SAML, OpenID Connect, OAuth, and these would be the clear benefits. We, in the AuthZen community, we want to aim for that degree of maturity, if you will, and awareness. Moving on. So this is what a simple request looks like. It's just a JSON payload. We've actually made a couple modifications in the latest draft that you can look in the public period review. We try to align it to make it easier to create SDKs and stuff, especially in gRPC land. So we introduced a type and ID, and then there's a sub-object. I don't have my example called properties where you can stick in additional attributes. It is, in a way, if you compare it to, say, Zacmol, which is where I come from, it is very similar, but simplified further, which means that writing a PEP should be even easier. And then the response is just a true false. There are things we're thinking of adding, of course, like contextual data. Why is it true? Why is it false? So that's for the future of AuthZen. And there's two more things that we want to work on in terms of the request response. One is a batch request and a batch response. So not just getting a single yes or single no, but if you want to ask 100 questions in one go, get 100 decisions back. We call that box scarring at AuthZen. And then the other thing is the search API. That's actually quite interesting because oftentimes in authorization, we don't just want to say, hey, can I view item 1? But rather we want to say, hey, tell me which items I can view. And you want to get a list of items back. That's search, or sometimes called partial evaluation. So that's the future of AuthZen. So if you're interested in taking part in that, please do join us. We're a bunch of funny people getting together on a weekly basis to talk about that. So moving on. Speaking of patterns, if we look at the world today, it is dominated by token-based authorization, by OAuth in particular. So how can we bridge the P-star-P architecture with that world? Eve Mailer of Event Factory came up with a session at IW, I think it was a year ago actually, where she said, okay, these are the different ways of doing authorization. This is how they should work together. One such way is the following picture here. Having the authorization server in OAuth, so the item that issues the token, before it issues an access token, have that call out to a policy decision point, whatever the implementation of the PDP is, policy or graph or whatever, it doesn't really matter, make it talk through AuthZen, get a list of claims that can be injected dynamically into the token so that the token can be returned to the client or the relying party and contain those dynamic claims. That should simplify token management in the OAuth authorization server. It should also align the claims with the policies that you have in your backend. And then, of course, the other integration is just plugging your resource server directly with the PDP. And that falls back on the traditional P-star-P architecture. What's interesting with this picture, though, is that it facilitates the integration because nearly every product already has an integration with OAuth and OpenID. So the integration cost is very low, as opposed to trying to figuring out a PEP for systems like Salesforce or SharePoint. That's actually quite hard. But if you follow that approach, it becomes so much easier. So it's a good next step towards fine-grained authorization and authorization that can truly do zero trust. Moving on. Very briefly, one of the standards that is growing right now is the abbreviated language for authorization. This is a language that came out back in 2012. I'm actually working under the guise of IETF to deliver an Alpha 2.0. If you're interested in that journey, please join me. Alpha is a very lightweight syntax to write authorization policies. We've tried on purpose to make it as easy to understand as possible. It is constrained. It can't do everything and anything. That's a departure, say, from Rego and Open Policy Agent, where the language is extremely complete by design to tackle with infrastructure. Alpha, on the other hand, is constrained to only focus on authorization use cases. And if you go on the following slide, I think I got a couple more points on that. It of course helps you deliver permit deny authorization. It is hierarchical, which is important because now it opens up the world to collaboration, which means that Andre, if you wanted to write one policy, and if I wanted to write one policy, we could both do that, and then Manuela could actually combine those two policies together, right? So that helps an enterprise write policies at their own pace, and then have an admin collect all those policies together, combine them in the way that they want to be combined, and then deploy them to an enterprise policy. And of course, Alpha, like the other languages, is attribute-based. You can use any attribute, and you can have conditions in the language that'll check the relationship between attributes, or just check that values are greater than, say, 18 if you want to drink a beer in Germany, or 21 if you're in the States. Next slide. Okay, so Andre, the icing on the cake. What about AI? How does that help at all? So AI, in my mind, can help us deliver a few different things for authorization that are, similar to what AI can do in other worlds. But first of all, before I get into those benefits, I'm happy to say that as of a week ago, we've actually released general release of our Axiomatic Policy Companion. You can all go click on that link here to. I should have made the link even longer, really, because that's too short, too easy to remember. To go play with the Policy Companion. The whole point of this first phase of the work that we've been doing at Axiomatics is to help people learn the authorization language, help people learn the way of thinking in terms of authorization, and then help people understand that it's not rocket science, really. You have a plain old requirement, you just go ahead and type it in and have the Policy Companion digest that for you and convert it into the authorization language that we use, which is Alpha. That's really the main goal of the Policy Companion. And there's a whole lot more we can think about. So let's dive right into the first aspect of the Policy Companion. This whole idea that because we use a policy language, Alpha, or it'd be the same with Cedar and Zackwell and other languages, there's a strong correlation between plain old English and that policy language. And so what you can do is have your AI companion take whatever you're writing in plain old English and actually digest it into something that makes a little bit more sense. Like any random plain old English might not be well suited to an authorization policy, but plain old English restructured by AI can then be mapped into Alpha in this example. And then, go ahead and to the following slide. The second point is that AI can help us understand whether what we're writing makes sense, right? And it kind of reminds me, I had a customer maybe 10 years ago. They were defense ministry in Europe, and they had given me like 20 pages worth of authorization policies, and they were great. Like they thought through their challenge really well, almost, because at the end of the 20 pages, they didn't have a single permit policy. It was all about, deny access from outside the country, deny access from a personal device, deny access from this and that. And at the end of the day, they didn't have a single permit rule. So my question was, well, what do you want to give access to? This is what AI can help us be. It can be a coach to say, well, look, you've written these requirements, great, makes sense. That one, however, might have a gap. And oh, by the way, your resource model isn't really clear. So AI can help you tell you that. We could take it even further, right? We could actually plug AI. We haven't done that yet, but we could plug AI into specific pieces of legislation and say, oh, you have SOX here, you have PCI here, you have export control here, you have GDPR here, you have FIRE or open banking. This is what your authorization should look like based on these legal texts. So that's, I think, where AI can play a huge part. But let's take it with a pinch of salt. AI doesn't always get everything right. So, remember, don't take the human out of the equation. You still want to review what AI is telling you. Moving on. And if you do that correctly, of course, it can help accelerate policy authoring from weeks to days or even hours, because it can find the right sources of attributes for you. It can find the right requirements for you. So it's really that whole idea that you can learn the language more quickly. And ideally, we're not telling the user to never learn the underlying technical language. It's always good to know the technical language, but see it as an aid, much like you have Microsoft Copilot for writing code. Copilot doesn't have the ambition to make you unlearn C# or whatever language you're dealing with. It has the ambition to help you write C# more quickly. It's the same story with authorization here. Moving on. And then The other aspect is oftentimes someone will write a policy and they'll go away, and you don't remember who wrote the policy and why they wrote the policy. Hopefully, what AI can help us do is tie the original requirement back to the underlying policy. And if you did lose those requirements, analyze the policies to understand why that policy had been written in the first place the way that it was written. That, I think, is actually one of the cooler use cases, because it will happen in your life, but the inherited set of policies, you don't know what those policies do. With AI, you can try to understand those policies and understand whether they have gaps. And we can move on. I think that was the last slide, actually. Yep, perfect.
Yeah.
Thanks, Andre.
Thanks, David. And what I would really like to highlight here, based on an approach in which a much larger group of persons is able to define a policy, first in natural language by getting feedback on is it accurate already, and then also in a kind of translation. I think that's really opportunity that helps us to apply a strong authorization model a much larger number of resources than it is today, and in a very structured way. Of course, we are doing a lot of authorization, but most of authorization today is really something hard-coded inside applications that are just asking for a specific role, and that's it. Yeah? But without having a good understanding of these kind of authorizations on a more generic level, and then bringing that together with the zero trust requirements we were talking before. Well, that's really building a bottleneck today, and I think that will help us all as an industry to move forward.
Yeah, I agree. And there's more stuff that are not mentioned in the slide that we could do in the future, which would be resource discovery. We could already sort of do resource discovery today in the enterprise, but it's fairly static. Maybe AI can be a better snoop. It sounds kind of scary when I say it that way, and figure out which other resources can benefit from authorization. Absolutely.
Mhm.
Great. Thank you, Andre and David, for this great presentation. I would say that we should shed some light now on some questions from our audience. And yeah, I will start with the first question. What is industry standard to provision these authorization data like user attributes, access controls? Either PEP should push that data to PDP in the beginning, or PDP should pull the data from the PEP.
Yeah,
Want to pick it up?
it's really good question. There's two in authorization systems today. There are really two major approaches. The traditional and perhaps the bigger approach today is to have the PDP, through the use of a PIP, of a policy information point, connect to underlying systems that contain the metadata. Those underlying systems could be LDAP, they could be SQL, they could be any number of technical sources. It could be REST endpoints. The one identity standard that we do see in that space is SCIM, SCIM, which I never remember what it stands for. I think System for Cross Identity Management, if I remember correctly, which can help you read data from underlying systems. So that's one standard. There is another kind of system, though, where, especially if you look at graph-based systems, OpenFGA as an example, where they have to suck in all the data up front. I don't know that there's any particular standard to do that. You could also use SCIM. Of course, you could use REST endpoints as well. But the difference between, say, an OpenFGA and a policy-based approach like Axiomatics is that in the policy-based approach, we will go figure the data as we need it. So if Andre says, hey, can Joe view record one? I, the PDP, will turn around to my PIP and say, hey, tell me who Joe is. Are they a manager? Are they an editor? So on and so forth. That's runtime retrieval of data. In the OpenFGA world, all the data is already in a closed system, so you have the data to reason on. That opens different opportunities on both sides. But at the end of the day, the plumbing itself, yeah, we could use SCIM, we could use other standards. One more thing I'll add is if you had a system that can't connect to a PEP or PDP, it's a closed system, maybe you could do something called provisioning. And what I mean by that is you could actually run through your configuration in the policy decision point, get a bunch of decisions beforehand. We're not doing runtime anymore. And then you could use SCIM to provision entitlements, to provision scopes to the target system. that makes sense. And there's more things we could expand on in that realm that we haven't really looked at yet.
Yeah, maybe to add to that. So to me, it sounds a little bit also that the question is around the approaches of what that we see, for instance, when it comes to open policy agents. Yeah? So having that kind of a lot of decisions happening in the enforcement point, decision point, it doesn't exactly implement that kind of architecture we have seen before. For runtime reasons, it's a kind of approach, but of course it's required to have all information to make that decision then at the enforcement point, which might be challenging as well. I would really say so. So first of all, I think we see a lot of improvements, discussions, and especially the David, what you mentioned around the AuthZen working groups that now move the industry forward. I think that will then also help on the long run having clear understanding what is the best approach in which situation. What are the cons and pros of the different approaches? Because there's always price to pay, no matter which path you follow there. But everything is better than hard coding complex authorization on a kind of business logic level inside the applications directly, because that is something what is not sufficient anymore in that zero trust world we are now in, having that kind of much more complex policy requirements. That's just not scaling.
All right, thank you. There's another question focusing on graph-based authorization. So why is graph-based authorization its own authorization model and not just a different way of storing or providing data for an attribute-based authorization decision?
Yeah, it's another really good question, Manuela. I want to reply a little tongue-in-cheek and say, does it matter? At the end of the day, you, the enterprise architect rolling out authorization, what you really want to make sure is that the authorization system that you're putting in place gives you the right degree of granularity, the right level of flexibility, and it gives you the right architecture so you can put in a PEP and a PDP, whatever that PDP may be running, right? If it's ACLs behind the scenes, or if it's graph behind the scenes, or if it's policy behind the scenes, right? So you want to have that level of granularity, visibility, auditability, because otherwise you kind of lose. Now, why graph? Why is graph a separate system? Historically, it's because it's been implemented with separate technology. Oftentimes, it doesn't have to be that way, by the way. Not all vendors do it that way. But oftentimes, it's been implemented on top of graph-based tech, and it targets graph-based APIs, for instance, and it focuses a lot on GraphQL. But one of the cool things, a close friend of mine is a huge proponent of graph-based authorization, so I'll give a shout out to him. One of the key benefits is that they claim to be zero code, right? So you have a graph on the panel, we can drop objects, you can link the objects together, and then you can determine access control. So it's a way more visual way, perhaps, of doing authorization. That being said, there's shortcomings as well. And typically in graph, you can only use the relationship as a means to define access control, but you can't easily do things like access control based on additional attributes or additional parameters, which is where you have to plug in a policy language. So if you plug in a policy language, then you fall back on PBAC. I think at the end of the day, those systems are not exclusive, right? You could use a graph-based system, if only to maintain reback relationship data in a store in a standard way, like you said, Manuela, right? Or the original question said. And then if you had some discretionary access control use cases, you could go back to access control lists, right? What I personally like about policy, to wrap it up, is that there's that close relationship between the original requirement and the actual technical implementation. That's, I think, what drives it for me. And then low code versus not low code, I think that when you have a policy, it's all a matter of UI and UX. Can you build a UI that hides the policy language, as we have done at Axiomatics for XACTWell in the past? And God knows XACTWell is a horrendous syntax, but with the right abstraction, with the right UI, no one cares what the underlying language is. So that's the main takeaway. But they're not mutually exclusive.
All right. Then a question, if you can explain why is it not sufficient to have MFA, RBAC, and CTNA implemented? Andre, maybe
So
you?
yeah, so that's often the kind of situation our customers are in today. So MFA is enrolled, enforced, and of course roles are assigned to users, and then a zero trust network access solution is deployed to ensure that applications are accessible via internet without going through a traditional VPN and having a kind of microsegmentation applied. And I think that's an excellent first step. But the missing part here comes really with a kind of using all the information available out there in a standardized way, as we have seen before in the approach NIST is recommending with a kind of 5 steps in the evaluation. There are a lot of aspects are not taken into consideration because it's well too complex to deal on that kind of more or less static level, because here we are talking about a kind of authorization. If you have access to the application, then you can access the zero trust network access gateway, and then it is as before, right? So there's not a kind of huge improvement there. There's no a clear understanding, bringing in the correlation we have discussed when it comes to device compliance for specific user groups. How can I leverage that? Or having also the detailed understanding. David showed example when it comes to fine-grained authorization. So it's a good first step, but it's not the end of the journey from a zero trust perspective.
Okay, great. And Andre, from your experience, are most clients targeted for the optimal level of zero trust maturity? And which of the zero trust pillars do you think holds the most significance for organizations today?
Yeah, well, of course, it's nothing where I would say there's kind of same replies to all organizations. I would say, of course, everybody wants to achieve as much as possible with a given budget, because there's always a constraints on budget and the resources. But it's often not from a kind of capability perspective, even if there are a few capabilities already which are more in the optimal level, then the question is it really applied to all resources, to all devices, to all users, or just to a smaller part of the population, just a smaller part of the applications? And that's the real life. Yeah, you have capabilities in place, but now you have to enroll it, making sure that you can apply it everywhere and can force it everywhere. And that's a very long journey. Of course, the identity pillar is very, very important, but the other pillars as well. It's from my point of view, always a good idea is having an understanding what risks do I mitigate, what impact does that have, and then what can I achieve with the budget and resources I have. So really figuring out with a given resource and budget, what is the best improvement from a security posture perspective for my organization. And that might be the case. I'm moving higher in one specific pillar, and another pillar I am not on that level yet.
Okay, we have one more additional question about standard integrations. So are there any standard integrations available, like Azure AD, Zscaler, ZPA, and so on, Okta? Can you say something about that?
Yes. So the short answer is yes, there is. I think you'll find that different vendors have different integrations. In the case of Axiomatics, we integrate with systems like SharePoint, we integrate with SAP, we integrate with most API gateways. So there are standard integrations out there. Other vendors might have a slightly different list, right? Number one. Number two, putting on my standards hat, one of the goals of AuthZen is to increase by tenfold that level of integration. What we're aiming for is what we call the OAuth moment. You know, going back to 15 years ago, no one did OAuth. Today, if you buy a SaaS, obviously it has to do OAuth and OpenID Connect, otherwise you're not going to buy the product, right? So we want to get to that level. We want to tell Salesforce and Workday and other companies, hey, it's time you opened up your authorization model and let us plug in an AuthZen compatible implementation so that you can do authorization in that system.
Great. One more question. What's in store for policy languages in the next 12 months?
Yeah, that's a really good question. So we saw in 2023, AWS came up with their own standard called Cedar. So that was possibly one of the biggest developments in 2023. In 2024, I've personally been working on Alpha 2.0, like I mentioned during the presentation. What I want to do is essentially Alpha is a great language. It's very simple, but it still has some baggage from XAML. I want to get rid of those. I've been working closely with two partners in the UK and in Germany to make that happen. And we're submitting the work to IETF. I had an initial presentation at IETF 120 in Vancouver a few months ago, and we're going to resubmit the work at IETF 121 in November in Dublin. So stay tuned. And if you want to learn more about Alpha and the work we're doing, you can go to alpha.guide and you can read up more on that website.
Perfect. Now we're reaching the top of the hour, and I would say that if you have any additional questions, then just send them over via email, and Andre and David are really happy to answer them. I really want to thank you, Andre and David, for this great presentation. Do you want to add anything else to the discussion?
Thanks for having me. It was a pleasure.
Thank you for being here.
Thanks a lot to David. Yeah, it was really great having that discussion here, and I enjoyed it a lot. I think all of us learned a lot of the insights you were sharing about all the discussions, especially when it comes to the AuthZen Working Group. So I really appreciate the effort of all you guys in helping us as an industry to get better when it comes to authorization.
Thanks. Yeah, and if you want to learn more, the next session on AuthZen is going to be at Nordic API Summit in Stockholm for those of you in Europe. And then, like I said, we're going to have an interop in California in October as well, the week after that. So if you want sunny weather, come to California. If you like the cold, come to Stockholm.
Yes. So thank you all for attending. Have a great day and see you in the next session. Thank you.
Thanks.
Have a great
Bye-bye.
day. Thanks.